is also the part of the Nova Gay expedition. What's the expedition? And we're working with some problem with that expedition. The problem is now our population growth. So in the Nova Gay, we need to know what is the population growth next 5 years, 10 years, or 20 years. What will be the population growth? We will create a simulator for that population growth. We're not sure whether the simulator will be the exact one, but we need to know some we have some idea that what's going on with this simulator. So what you need to do, the learning outcomes of this, the project name is Population Growth Simulator, the GAE Viability Estimator. And the learning outcomes are you need to apply loops that you already have learned, if statement, and use a defined function that you already have done for the last project. Also to structure and control flow of your program. Make sure you use the conditional execution for the main function call. You need to generate a sequence of data points. So sequence means what we have done in the last class, like list. Well, you need to create a list. You need to generate a list of those data points that simulate a population over time using the mathematical modeling. There will be a mathematical model. You need to utilize list to store and manage the population values for each simulation steps. You need to develop a simple simulation using code to model the real world population growth in a constrained environment. You need to write simulation result to an external text file for further analysis and verification. So previously what we have done is like we print the output to the terminal, but now we are not printing to the terminal. We're going to store those information in text file. Use the command line arguments to pass input values to your program, enhancing the usability and automation. Again, previously what we have done, we have used input function to get the user's input, but now we are not using the input function. Rather, we'll be using the command line argument. I'll be discussing those things later today. What is the command line argument, how you can use those things. But yeah, those are the required things, or those are the learning outcomes for this project. Again, the mission brief, as the Earth entered its final collapse, the last wave of evacuees boarded the Nova Exodus fleet, a generation ship bound for Gaia 4, an Earth-like planet capable of supporting human life. However, the planet's biosphere is still unstable, and the Colonial Council must determine whether its environment can sustain a growing human population. To access the viability of the mission, scientists have developed the Gaia Viability Estimator, a simulation tool based on the logistic growth model. Using the data from environment sensors, the estimator projects how a colony's population would grow under resource-constrained conditions on Gaia 4. This simulation helps inform whether additional shelters should be sent or if strict population controls are required. So those are some precautions for the admin section of the Gaia 4. But we need to know what is the estimator, how we can generate an estimation. Well, we'll be using a logistic equation. So you will implement a population growth simulator using a logistic equation, which models how population grow under the limited resources. This is the very well-known type of equation. So you can see here, P suffix n equal R multiply P suffix n minus 1 multiply 1 minus P suffix n minus 1, where Pn is the population at a percentage of maximum capacity at time step n. That means Pn, see if I'm saying P4, it is the time step of 4. If it is P0, it is the time step of 0. That means the initial population. R is the growth rate. What will be the growth rate? we'll be deciding those things later, how we can get the growth rate. Then Pn minus 1 is the population of the previous time step. Like, for example, this is 2026. If we'd like to get the population of 2025, maybe Pn is the 2026. Pn minus 1 is 2026 minus 1 is 25, like the previous time step. What your program will do, your program will take input from command line. So this time we are getting the input from command line, not from the input function. Then the next thing is simulate the population growth over a number of steps. So you'll be given a number of steps, like how many times you will iterate the logistic equation. If it's like a 10, you'll run this simulator 10 times. If it's 100, it simulate these things by 100 times. And finally, you'll write the results to a file in a readable format. Typically, we'll be using here a text file, .txt. Now, what your program must do, it takes 4 command line arguments. What are those 4 command line arguments? The first one is initial population. And the initial population is a percentage of total population. And the value range for the initial population is in between 0 to 1. So you can see here P0. That means it is the initial population. And the range is 0 to 1. Now my question is 0 is a valid number? Is 1 is a valid number? No, it should be at least greater than 0, at least less than 1. That means in between 0.0001 to 0.99999. So those are the valid numbers. So you need to validate those things like input validation. Then the growth rate, a float value between 0 to 4. Again, the rate is in between 0 to 4. 0 is not a valid number. 4 is not a valid number. 0.0001 is a valid one. 3.9999 is a valid number, not the 4. Okay. The third input is number of simulation steps. It should be a positive integer. That means -1 is also not a valid number here. How about a 0? 0 is not a positive integer in this particular case. At least 1. So since it is an integer, that means there is no fractional value here, like not 0.001. So 0.01 is not a valid number here, but 1 is a valid number here. So 1 to 3 is the valid number. I'm sorry. For the simulation step, 1 to onward, any positive number is a valid number. The fourth argument or input is the output file name, where you're storing the information. I'm giving you an example like population.txt, but in your case, it can be a different one. You can use this one as well, but it doesn't matter. It should be a file name. And for this particular project, we'll be using a .txt file, a text file. Then what next? Use a function to compute the next population value. You need to write a function that can compute the next population value. That means with this logistic equation, you need to create a function where the inputs are n-1 and the outputs are n, given that there is r there. So r and pn-1 are the input and pn is the output. So you need to compute the next population value. And make sure you use a list to store each time step population. So whenever you are getting the value, you need to store those things in a list. We'll be discussing list in a minute. We also have discussed in the last class, but we'll see how we can populate this list. You'll be using a list to gather those information. And make sure you validate those inputs. What are those inputs? Those are the inputs. You need to validate those inputs. For example, like growth rate in proper range. Finally, write the time and population values to the output file with values rounded to 2 decimal places. In this particular case, you need to round by 3 decimal places. Keep in mind, you need to round it, not f string. You need to use the round function to round the value. The same thing that you have used a main function, and make sure you use the conditional execution block, and there will be no global execution code of the function call outside the function call. The global execution code means like your code should be in between your function.
So to use the command line arguments, don't we have to import? So shouldn't that import?
Yeah, import is a part of global code. Yeah, in that particular case, it is okay. Whenever I'm saying global code, import is fine.
Okay.
Import cannot be treated as a global code in this particular course. Okay. Now, what are the required things or rubric? So you need to write the output to a file formatted correctly with 2 decimal places, works with any valid parameter input, uses for or while loops. This time, you can use either a for loop or a while loop. You don't need to write both. If statement and user-defined function. Code in a file name this file, Gaia_growth_simulator.py. Your code contains a main function with conditional execution. The logistic equation is implemented in its own function. That means you need to write a function that can only serve the purpose of logistic equation. Correctly process command line argument and validates the input. Uses the list to capture all population values over the time, validates the values are within acceptable range, and follows the proper coding style like snake case, variable naming, or camel case things. Here is an example run. So you can see here, Python 3 is the software that we are using to run our code. Then our file name, and then there are some parameters. What are those parameters? The first one is the initial population. Second one is the growth rate. Third one is the number of iteration. And fourth one is the file name. You need to follow this particular pattern. So this is basically, so previously what you have done, Python 3 and your file name. But now you are not just calling the file name. In addition to that, you need to add those information. So those are basically our command line things, but I'll be discussing later. And then your output file should be like this way. 0 is the iteration starting from initial population, then a tab line, like 4 spaces, and then the population. So initial population was 0.1. So here I have put it 1.100. So both rounded and F string. Okay. Not only the F string. Until the number of iterations. So our number of iterations is 20. So 20 is included here. So from 0 to 20, that means there will be 21 iteration. Like 21 items in the output.txt file or whatever the file name of your text file. Okay. So if you're writing like 0 to 19, it's not valid. 1 to 20, it's not valid. From initial population until the number of iteration ends. Okay. And each line represents the time step and simulated population value rounded to 2 decimal places. Okay. Now, any question about the project description? Okay. What are the inputs of this project? How many inputs? 1? How many? 4? What are those?
Population, percentage, growth rate.
Initial population, then the growth rate, number of simulation steps, and output file name. So those are the 4 input things. But do not use input function here. You need to use those input through the command line parameter like this way. Then I'll show you how you can get those values from your program. And then what's the output? Output, whatever it is, it should be stored in a file, not in the terminal, not just print. You need to print it or write it to the file. And file name is given here. So for example, the file name is like output.txt. You need to create a file with that name and then put those information to that file. And what is the format of the output? Iteration number and the population rate or the population percentage. But it should start from 0, ends with the last number of iteration. Any question? Any question about the inputs, outputs, or output? Now, we haven't covered the file operation yet, but the next week we'll be covering the file operation. So you'll know how you can write to the file, read from a file. But what you have already learned is like the list, a sequence, right? For this project, you need to generate next population from the previous population and store it to a list. Finally, from the list, you'll print or you will just store those values to a file. Okay. Now, the important thing is here, you need to write user-defined function, but at least you need to write one function, which is like our logistic equation function. This is our logistic equation. And what it does, with the given previous population and the growth rate, it will generate a next population. So what's the inputs and outputs of this particular function? The growth rate and the previous population. And what's the output? The next population. Do not print anything inside that function. Just I told you in the last week that whenever you're writing a function, do not print anything inside a function unless it's the main function. The purpose of this function is to do something. With given input, it will generate something and return the output. That's it. Unless it's the main function. In the main function, you need to take the input, not using the input function, but using command line parameter, then process it. Whenever you have the output, you can print it, but not for this project. In this project, you need to print it to a file. That means you need to write to a file. But I'll show you in the next week how you can write to a file. Any question about the project? Do you understand the project specification?
Yeah.
Okay. Okay, so my suggestion is, since we haven't covered the file operation, so what you can do, you can start working with your project, but at the very end, just print the output with the print statement. Whenever you learn how to write to a file, then you print those things to the file or write to the file. Okay. Any other question? No? Are you all good? Okay.